Hi, Dennis.
Hello, Anton.
I have a bowl full of water in my hands. Why do you think I have a bowl with water in my hands?
Tell me, please.
Because the name of this episode is Water. I've brought water. What have you brought?
Cans.
Cans. Well,
You've brought the water and I've brought the cans.
okay, what's the name of the experiment?
The name of the experiment is Collapsing Cans.
Collapsing Cans. A wonderful name, though it's unclear what the water has to do with it. In fact, this experiment demonstrates an amazing difference in the properties of different aggregate states of water. In the can which we heat, there's a little liquid poured. When it boils, the whole space of the can is filled with steam. Molecules of water in it diverge from each other. When we lower the can into the bowl, holding it the whole downward so that there is no air access, the water vapor inside cools, turning into water, with the molecules attracted to each other. A low pressure is created, and our atmospheric pressure simply, bang, squeezes the can. Well, I therefore should remember that water is, of course, a very important participant in this experiment. But in principle, they collapse. Well, thanks to our atmospheric pressure. But I have a question. These were small aluminum cans. And what about such 5-liter aluminum cans? Will it collapse too? If you heat it up, put it into water, will it make like a bang?
It can be collapsed the same way. You'll have to heat it a bit more. You'll need a little more water, a little bigger vessel, but you can collapse it in the same way. Look, here's a barrel.
This big one.
But it's a barrel, not a can. Help me carry it? Yes, that's right.
A barrel.
It can be collapsed just as easily, but the conditions will be a bit different.
So you're suggesting that you'll be experimenting with it in the lab?
Yes.
And then you'll show it to me.
Okay. Well, it's time to collapse this barrel.
So we have a barrel with the volume of 1 barrel. It's about 150 liters. Gas cylinders, a gas burner, and quite a big one. And an inflatable wading pool. Well, we must have it.
I've bought an inflatable wading pool with a diameter of, in my opinion, 1 meter 70 centimeters. Maybe it's even a bit big, but big isn't small.
Well, it's time to shout, Dennis set fire to it. Now the main thing is to leave the lid open to prevent the barrel from bursting from internal pressure. It's getting hot, in the most direct sense of the word. Dennis is controlling the temperature of the barrel with a thermal imaging device. 78 degrees. Not enough. And what if we won't be able to bring the water to a boil? But no, it seems that everything is going as planned.
It's time.
Let's move on to the water procedures. This barrel can collapse after every watering. Not yet. Maybe now. The top is slowly bending and... I gave Dennis the task to blow up, or rather, on the contrary, to collapse a large steel barrel. He kind of managed to do it. To make a long story short, now he is going to demonstrate the experiment specially for us. Whoa! I have the most important question. Can I go now?
No way. I cannot hold it on my own. Try to get around the fire from that side.
Excellent. Where are we going to put it?
Right now.
Straight with our hands.
Right with our hands.
Let's take it.
Just be careful.
I see, yes.
It can be roasted.
I see everything.
Higher, higher.
Okay. You are already familiar with the ingredients. A barrel with thick walls, a gas burner, and an inflatable wading pool. Now the water inside the barrel is warming up, creating steam. Then we are removing the barrel from the fire, putting it into the pool, and then we'll see. That's it. Time to close the lid. Do you remember? We turn the cans the opening side down. Here, this trick won't work. Try. Turn this behemoth.
Okay, wait, give me a little more. Okay, let's carry it.
Oh.
Higher. Careful. Let's put it down.
And then we start playing ping pong with buckets. Dennis and I will take turns to water the barrel. Okay. Now the water steam inside is cooling, turning into water. Its volume is less than the volume of steam. The pressure in the barrel is dropping. Our atmospheric pressure is squeezing the walls, and and it goes on shrinking.
Keep shrinking.
And now, once again, in slow motion. Beauty! By the way, I almost forgot. Do you remember our 5-liter can? We promised to collapse it, and we did it.
Okay.
Start.
Opa!